Hi, welcome to the Shikong Mathematical Statistics lecture series. And today we're going to work on the problem regarding to the maximum likelihood estimator. So the question we're going to work on today is pretty simple and very basic, how to find the maximum likelihood estimator for certain parameters and with a certain distribution. Okay, so today's the problems here is we have x1, x2, xn is an independent random sample from the Poisson distributions with the parameter lambda. And we want to find the maximum likelihood estimator for the lambdas here. Like I said, this is a very basic and fundamental problem to how to find the MLE for a certain parameter. Okay, so let's go to the whiteboard and let's go ahead and start here. Okay, so in here, right? So for the x1, so let's try to write here. So this is x1, x2 to the xn. So this is a Poisson with lambda. Okay, in order to do the maximum likelihood estimator, first let's take a look at what is the PDF for each for the x's here. So if this is the Poisson, then the density function will be the x factorial, and then here is lambda x e to the negative lambda here. All right, so the step number one we always want to do is find the likelihood functions here. So I will use a capital L. So this is x1, x2 to the xn to the lambda. So the likelihood function will just be you multiply each PDF, right? So here it will be x1 factorial lambda x1 e to the negative lambda times x2 factorial lambda x2 e to the negative lambda, and all the way to here, xn to the factorial lambda, the xn, and the e to the negative lambda. Then we are going to use a little bit of algebra to combine it. So the denominator is really you just multiply them, right? So it's x1 factorial times x2 factorial all the way times xn factorial. Then for the lambda, the x1, these things here, right? So when you times it, will just be what? Will just be add the components, right? So this will be the lambda summation xi, I from 1 to n here. Then the remaining here, this is the e to the negative lambda, e to the negative lambda, e to the negative lambda. It will be what? It negative what? How many lambda we have? We have n lambdas here, right? So in order to find the maximum likelihood, just like the calculus, we say we want to take the derivative and set the first derivative equal to 0. But this is a kind of a complicated function. So the easy way to do it is let's just take log functions for that. Okay, so in here, if I just take the log functions, ln for the likelihood functions and the xn to the lambda. Sometimes you will see in some like textbook instead of use the ln, so you will just see the people use log like this, x1, x2 to the xn, but basically the mean is the natural log, so doesn't matter, it's just notations here. Okay, so by using the log functions characteristics, so I know here, right? So the log to the exponents, you can put a summation xi, then you have a natural log lambda, then the natural log to the e just cancel out, will be the n lambda. And then the buttons here is just the minus. Remember that if you take a natural log both sides here, and then if you divide it, it's just a minus, right? So it's a minus natural log x1 factorial, x2 factorial to the xn factorial. Okay, I don't really, I can separate that, but it really doesn't matter because when I take the derivative of so if I take the derivative of the natural log, my likelihood functions, Okay, so what is the derivative I'm taking with respect to the parameter lambdas, right? So when you do that, and then in here, so I will know this is my natural log lambda. So from the calculus, I know the derivative of natural log is what? It's lambda. Then the summation xi is just what? Is the, it's a constant. Then here the n lambda, you take the derivative with lambda with n. And the whole list terms here, right? So the whole list term, this is x1, x2 to xn, has nothing to do with the lambda. So the derivative we treat as a constant is 0. All right, so after that, okay, so we said, we will set this one's equal to 0 and solve for lambda. And so now if you set this one equal to 0, then I will set summation xi, the lambda equal to what? Equal to nth, right? So that's why if in here I can say the lambda, the estimator lambdas at will be the summation xi over nth here. So that is the summation xi over n. This is what we call this x bars here. So that's how do we prove the MLE of the lambda is equal to the x bar. Okay, so this is a very simple proof here. So the steps here basically is like you find the likelihood function, and most of the time you might need to take the natural log of both sides to make the calculation a little bit easier. Then you take the first derivative about the parameter you are interested in, then set equal to 0 and solve for that. All right, that's it. Like I said, this is a very basic and very easy problem to work with. Okay, and I hope this is helpful. And looking forward to our next video, we're going to get to the next level about MLEs here. All right, talk to you later. Okay, bye-bye.